bilinear or Mobius transformation. Now the definition is a transformation W equal to AZ plus B over CZ plus D, where A, B, C, D are complex constants with AD minus BC not equal to 0, is called a bilinear transformation. Is called a bilinear transformation. Now here AD minus BC is also called determinant of the bilinear transformation. AD minus BC is called determinant of the bilinear transformation. Bilinear transformation W equal to AZ plus B over CZ plus D. And every transformation W equal to AZ plus B over CZ plus D, where AD minus BC is not equal to 0, is the combination of the four basic transformations, which are W equal to Z plus C, the translation. Second one is rotation, W equal to Z e power iota theta naught. Third one is magnification, W equal to CZ. And fourth one is inversion, that is W equal to 1 over Z. The combination of these, it gives the bilinear transformation. The next is cross ratio. Cross ratio. Suppose I have 4 points. If there are 4 points Z1, Z2, Z3, Z4 taken in order, then the ratio, how we will find the ratio? Z1, Z2, Z3, Z4. It is traversed in anti-clockwise direction. Then the ratio Z1 minus Z2 into Z3 minus Z4 divided by Z2 minus Z3 into Z4 minus Z1. One thing is to be noted, that here I am preserving this direction, this anti-clockwise direction. Z4 minus Z1 is called the cross ratio, of Z1, Z2, Z3 and Z4. And the bilinear transformation, it preserves the cross ratio of 4 points. We discuss this theorem. A bilinear transformation, preserves the cross ratio cross ratio of 4 points. Now I consider the bilinear transformation. Let the bilinear transformation be, let the bilinear transformation be W equal to AZ plus B over CZ plus D, where AD minus BC is not equal to 0. Now I take, let W1, W2, W3, W4 be the images of Z1, Z2, Z3, Z4 respectively. Therefore W1 will be AZ1 plus B, CZ1 plus D, W2 AZ2 plus B, CZ2 plus D, W3 AZ3 plus B, CZ3 plus D, and W4 AZ4 plus B, CZ4 plus D. Now what was the cross ratio? Z1, Z2, Z3, Z4. It in anti-clockwise direction. It was Z1 minus Z2, Z3 minus Z4 over Z2 minus Z3 divided by into Z4 minus Z1. Now I will calculate W1 minus W2. It is equal to AZ1 plus B, CZ1 plus D minus AZ2 plus B, CZ2 plus D, equal to CZ1 plus D into CZ2 plus D, AZ1 plus B into CZ2 plus D minus AZ2 plus B, CZ2 plus D, equal to CZ1 plus D, equal to CZ1 plus D, CZ2 plus D. Now I will open the brackets. AC Z1 Z2 plus AD Z1 plus BC Z2 plus B into D minus AC Z1 Z2 plus AD Z2 plus BC Z1 plus B into D, equal to AC Z1 Z2 is cancelled out and BD is cancelled out. From here AD Z1 plus BC Z2 minus AD Z2 minus BC Z1 divided by CZ1 plus D over CZ2 plus D, equal to, from these two AD is common, Z1 minus Z2, from these two minus BC common, Z1 minus Z2, CZ1 plus D, CZ2 plus D, that is Z1 minus Z2 common, inside I get AD minus BC over CZ1 plus D into CZ2 plus D. This is the value of W1 minus W2. Similarly, we will get, this is the value of W1 minus W2. Similarly, we will get the value of W2 minus W3 equal to AD minus BC CZ2 plus D into CZ3 plus D into Z2 minus Z3 W3 minus W4 equal to AD minus BC CZ3 plus D CZ4 plus D Z3 minus Z4 and last one W4 minus W1. This will be equal to AD minus BC CZ4 plus D CZ1 plus D into Z4 minus Z1, and from these we will get Z1 minus Z2 into Z3 minus Z4 divided by Z2 minus Z3 into Z4 minus Z1. It is equal to W1 minus W2 W3 minus W4 over W2 minus W3 W4 minus W1, and therefore the cross ratio, it is preserved under the bilinear transformation. Now next definition, invariant or fixed points. Next definition, invariant or fixed points. The points which coincide with their transformations are called invariant points, of the transformation. That is, if z equal to f of z, the value of the point is equal to its image, then the point will be called invariant point, and here the transformation is w equal to f of z. Now we will solve some questions based on the bilinear transformation. First sum is, find the bilinear transformation. Find the bilinear transformation which maps the points z equal to 1 minus iota minus 1 to the points w equal to iota 0 minus iota respectively. Show also that the transformation maps the region outside the circle, mod z equal to 1 into the half plane real part of w greater than equal to 0. Now first of all I will find the bilinear transformation, and for this I will use this theorem that under bilinear transformation the cross ratio, it is preserved. Now here it is given that the transformation maps the points z equal to 1 comma minus iota comma minus 1 to the points W equal to iota, 0, minus iota. Now I will find the cross ratio of these. Now first, Z1 minus iota minus 1. For this, anti-clockwise direction, this will be in the numerator. From here you will get Z minus 1 minus iota minus plus 1 divided by 1 minus plus iota, this minus this, minus 1 minus Z equal to, other is W iota, 0, minus iota. Equal to W minus iota into 0 plus iota divided by iota minus 0 into minus iota minus W, that is, now I write it again, Z minus 1 over minus iota plus 1 divided by 1 plus iota minus 1 minus Z equal to W minus iota divided by 0 plus iota into 0 plus iota divided by iota minus 0 into minus iota minus W, that is Z minus 1 into minus iota plus 1 over 1 plus iota, negative sign common, 1 plus Z equal to W minus iota into iota over iota, negative sign common, W plus iota. Iota cancel, and this negative sign is also cancelled out. Now opening the brackets, minus iota Z plus Z plus iota minus 1 over 1 plus Z plus iota Z equal to W minus iota over W plus iota. Now applying component 1 dividendo, you will get minus iota plus Z plus iota minus 1 plus denominator 1 plus Z plus iota Z over minus iota Z plus iota minus 1, negative sign, 1 plus Z plus iota Z equal to W minus iota plus W plus iota divided by W minus iota minus W plus iota, that is, now here Z plus Z will give you 2Z, iota Z is cancelled out, 1 is cancelled out, iota plus iota, 2 iota divided by minus 2 iota Z minus 1 minus 2, Z is cancelled, iota and iota is cancelled, here iota is cancelled, and in the denominator W is cancelled, equal to 2W minus 2 iota, that is 2 common Z plus iota divided by minus 2 common iota Z plus 1 equal to W over minus iota. Negative sign is cancelled out, 2 is cancelled, cross multiply, W equal to iota Z plus iota square over iota Z plus 1, that is W equal to iota Z minus 1 over iota Z plus 1. Or you can find the value of Z from here. For that I get iota zw plus w equal to iota z minus 1. That is iota zw minus iota z equal to minus 1 minus w, or iota z common, w minus 1 equal to minus 1 common 1 plus w. That is iota z is minus w plus 1 over w minus 1, z equal to minus 1 over iota w plus 1 w minus 1, minus 1 can be written as iota square. That is z is iota w plus 1 over w minus 1. Now in the statement we had to find the map of the region outside the circle mod z equal to 1. Therefore outside the circle is given by mod z greater than equal to 1 is transformed into the region mod w plus 1 over w minus 1 greater than equal to 1. Mod of iota is 1. Therefore from here we get mod w plus 1 is greater than equal to mod w minus 1, or mod w is u plus iota v plus 1 is greater than equal to mod u plus iota v minus 1, or u plus 1 plus iota v mod greater than equal to u minus 1 plus iota v. That is under root of u plus 1 whole square plus v square is greater than equal to under root of u minus 1 whole square plus v square. Squaring both sides you will get u square plus 2u plus 1 plus v square is greater than equal to u square minus 2u plus 1 plus v square. Now these terms are cancelled out. From here you will get 4u greater than equal to 0, that is u greater than equal to 0, or real part of w is greater than equal to 0. That means the outside of the circle mod z equal to 1 is transformed into half plane real w greater than equal to 0. Now next sum. Next question. Find the bilinear transformation. Find the bilinear transformation which maps the points z equal to 0 minus 1 iota onto w equal to iota 0 infinity. Also find the image of the circle mod z equal to 1. Now here the points are z 0 minus 1 iota and other is w iota 0 infinity. Now the direction is anti-clockwise. From here you will get z minus 0 minus 1 minus iota over 0 plus 1 into iota minus z equal to. Now I have to manage this infinity. For that I just write these points as w1, w2, w3, w4. This can be written as w1 minus w2 into w3 minus w4 divided by w2 minus w3 over into w4 minus w1. w1 minus w2, w3 minus w4 W2 minus W3, W4 minus W1. From here I get Z, negative sign common, 1 plus iota, 1. From here negative sign common, Z minus iota, equal to, now here W4 is infinity. I will divide numerator and denominator by W4. W1 minus W2, W3 over W4 minus 1, W2 minus W3 as it is, 1 minus W1 over W4, and 1 over infinity is 0. This negative negative cancelled. Z plus iota Z divided by Z minus iota equal to, W1 is W, W2 is iota, this becomes 0, minus 1. W2 is iota, W3 is 0, 1 minus 0. That is Z plus iota Z over Z minus iota is W minus iota into minus 1 over iota. Cross multiply by iota. This will give you Z iota plus iota square Z divided by Z minus iota is minus W plus iota. That is W equal to iota minus Z iota minus Z, Z minus iota. I have taken this term to the right hand side. Take LCM. Z minus iota, iota Z minus iota square minus iota Z minus minus plus Z. Iota Z is cancelled out. From here I get W equal to Z, iota square is minus, minus minus plus 1, Z plus 1 over Z minus iota. Now W is this, or this implies, from here I will find the value of Z. WZ minus iota W equal to Z plus 1, WZ minus Z equal to iota W plus 1, Z common, W plus 1 equal to iota W plus 1. That is, Z is iota W plus 1 over W, here is W minus 1. Our circle was mod Z equal to 1. Therefore, iota W plus 1 over W minus 1 equal to 1. That is, mod of iota W is U plus iota V plus 1 equal to mod of U plus iota V minus 1. That is iota U plus iota square V plus 1 equal to U minus 1 plus iota V. That is minus V plus 1 plus iota U is U minus 1 plus iota V mod. Therefore, under root of minus V plus 1 whole square plus U square equal to U minus 1 whole square plus V square. That is, squaring both sides, under root will be cancelled out. From here, you will get V square plus 1 minus 2V plus U square equal to U square minus 2U plus 1 plus V square. V square, V square, U square, U square, and 1 is cancelled out. From here, we get 2U minus 2V equal to 0. That is U minus V equal to 0. That is U equal to V. That means the image of the circle. Therefore, image of the circle mod Z equal to 1 in Z plane is a straight line, making an angle of 45 degree with u axis and passing through origin in W plane. Or you can also write that the image of circle mod z equal to 1 in z plane is the straight line u equal to v in W plane. That's all. Thanks.